All right, everybody, welcome to Wednesday. I'm just going to do a short video today and assign, starting at 11 o'clock, a quizzes that I want you guys to do by Thursday at midnight. And then tomorrow I'm going to do just a little more of the intro to quadratics so that maybe on Friday we can start doing math stuff and solving the quadratics. So I just want to make this quick today. This is page 4 in your packet, which if you can't print, I'm going to try to just take this and put it into maybe a Google Doc so that you can do it. Some of you have been asking, how do I submit homework? Do the best you can. If you can't print it out and take a picture, then we can find other options. But if you can, take a picture of what you're doing, send it to me. Some of you are able to just type in the answers and send that back, especially if it's through Google Classroom. You have your own version of it, so you just type on there and then hit submit. Finally, you might be able to use what I'm using, which is called Kami, Kami. I believe that might be on there. The last thing is check Google Classroom for this, which is the ability to click on and get your own Texas Instrument 84 on the computer, and then you don't have to worry about having your own actual calculator on you, or if you don't have one. So I just want you to try this one page here. All right. By the way, the joke of the day is that I keep looking for optometrist jokes, but they keep getting cornea and cornea. Hope you get that. So quadratic functions have to be ax squared plus bx plus c equals 0. If something is on the other side, like the 2x is on this side, you have to bring it over here as negative 2x. So in this case, whatever is in front of the x squared is my a, whatever's in front of the x is b, and the number by itself is c. Okay? So if you look down to here, my a would be 1, my b would be -7, and my c would be 10. All right, so the x-intercepts when y equals 0 in the parabola ax squared plus bx plus c are called roots or zeros or solutions. I don't care which ones you use. You're probably going to hear roots and zeros. But if you hear solutions, that means we're probably solving it. How many roots are possible? Well, roots are where it crosses this x-axis, okay? And because this is to the second power, the answer is either it's going to cross twice or under that, which means once or never. So I'm going to show you, and by the way, they could be upside down or regular. If this A is positive, it's a regular U, and if that A is negative, it's an upside down U. So hopefully this stuff helps. All right, I'm going to start with 2 solutions, or 2 zeros, or 2 roots. Okay, what would that look like? Well, it would have to cross twice. So this is upside down. All right, let me try to make that a little thicker so that you can see. All right, and there's my U-shaped, and hopefully you see it crosses 2 times. It could also cross just once. And if it crosses once, that means that the tip of the max or min is hitting the x-axis. So I'm going to show you that would be like, hey, it only hits once, and it would look like that. Okay, hopefully this helps. And we'll try one more in a different color. What about never hitting? Well, that means there's no solution, which means if you were trying to solve it, hey, what's the answer? How many times do they have zeros? It would be no solution, imaginary numbers. So that would be, for example, this. See how it never hits? 0 solutions. Okay, or something like this, 0 solutions. Okay, so hopefully that helps you guys. You can identify the roots by just counting boxes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, -6. Those would be your answers. Whereas this one would be 1, 2, 3, maybe 4 or 5. Again, it's a little bit of a thick line. So hopefully that helps. This is going to be quick. Again, this is the last part. And I want you guys to understand this. So given the following graph on the left, it's x squared minus 7x plus 10. Answer the following questions. So the first thing it says is, what is the axis of symmetry? Well, you might say this looks like 1, 2, 3. And again, the axis of symmetry is the line that splits it down the middle. Okay, it makes a mirror image, or it takes the parabola and cuts it in half. Well, you might say, Mr. C, it looks like it's somewhere over here. But you don't want to be partially correct. You want to be exactly correct. So what is that line? You might say that that's right between 3 and 4. But you want to be exact. So there is a formula that you could use to find the exact answer. And the formula is negative b over 2a. And we always say x equals. So x equals negative b over 2a. Well, b is negative 7. So if b is negative 7, then negative b is a positive 7. So b here is negative 7. So negative b is positive 7. And then 2 times 1. Well, where did I get 2 times 1? Well, a is 1. How do I know a is 1? There's really a 1 in there. Now, 7 divided by 2 is 3.5. So the answer is x equals 3.5 for the line that splits it down the middle, which is what you probably guessed. It looks about 3.5. Now, the turning point is 3.5 comma something. The 3.5 comes from what we just had. As you see, the dot of the 3.5 is a little bit below the x-axis. So it looks like 3.5 comma negative 2, but we don't know. So how do you find that out? You plug the 3.5 back in for x. You plug the 3.5 back in for x. Now, if you have a calculator, just plug 3.5 in. So what you're going to type in a calculator is 3.5 squared minus 7 times 3.5 plus 10. And I already did that for you. So we said the answer should be about negative 2. And look, 3.5 squared minus 7 times 3.5 plus 10 is negative 2.25. So it's not negative 2. It's negative 2.25. Negative 2.25. So I'm going to write that in. Negative 2.25. Okay? And that's your turning point. Is the turning point a max or a min? It's a min. How come? Anytime the letter or the number in front of x squared is positive, it's a minimum because you're going to have a low point. It's going to look like a U or a smiley. Okay? So positive smiley face. If that happened to be a negative number, it would be a frown face. How many zeros are there? 2. Hopefully you guys understand why. What are the solutions to this equation? Well, the solutions are where it crosses. So right here, that's positive 2 and 5. Now, the other thing you could have realized is if this is 2 and 5, then the halfway point is 3.5, and that's where you get your line of symmetry. So that's where that 3.5 comes from. All right, finally, what are they called? Whatever you want to call them. Zeros, roots, solutions. Now, what they wanted you to do is work algebraically. We haven't done this yet. This is what we'll do later in the week or Monday. I just want you could skip it, but I just want you to understand. If you were to factor this, you would have to go and make your x, right? So you make your x and you go, what multiplies to 1 times 10, but adds to negative 7? Well, the numbers that multiply to 10, but add to negative 7 are negative 5 and negative 2. But what do you notice about that? And by the way, then you'd get this, x minus 5 and x minus 2. What do you notice about your answers? Well, your answers came out to be positive 5 and positive 2. So the answers are opposite to whatever you get in your factor. Okay? So the answers are positive 5 and positive 2. And I'll show you how we would solve that algebraically. We would just have to set them equal to 0, and that's something we haven't done. All right. So I'm going to ask you guys to do one question for me as long as this works. If not, don't worry, but I'm going to try and have you guys answer one question on the video. Here it is. Okay. And hope you guys have a great day.